This is an intro problem. So we'll start with this vocab word sample space and what that means. That means all the numbers in the world, as far as you're concerned, are right here. There's no other number that exists. So when we get to these problems, these parts of the problem going down from there, you have to pretend the only numbers that exist are the ones that are given to you in the sample space. So list all the outcomes for which A, and I'm going to write this as, let's see, I'm going to say A or B for that first notation right there. And for the second one, I'm going to say A and B, just to be a little more clear about what these things mean. So if I say A or B, I mean all the numbers that are either in A or in B. So let's start going down the list. There's, and I'm going to use set notation here. There's 2, right? That's the first one right there. And there's the number 4 and the number 6. And where are these things coming from? Well, there's 4, there's 6. I don't need to repeat myself, so I'm not going to say 2 twice. But the next number I see is 12 from the bottom, 17 from the bottom again. Okay, 12 and 17. And then there's 18 from A, and 27 and 29. Okay, so there's 18, 27, and 29. That's the set of all numbers that are either in A or in B. Could be either one. Now the next one is a little more restrictive. It says list all the outcomes for A and B, right? Everything that's in A and B. So let me clear this space a little bit. And I'm going to look for the numbers that are only in both. There's 1. Okay, the number 2. So there's 2. And I see 4, but 4 doesn't match event B. I see 6, but that doesn't match event A. 12, 17, 20. I think 29 is the only other number in here that is in both sets. So I'm going to say 2 and 29, and that's it. And now it says, what's the complement of A? Okay, so make sure you understand what this little C thing means right there. That means complement. You can think of that as the word not in logic space, okay? It means what are all the things that are not in A? Now here's where that point I mentioned earlier comes in really handy. We want all the numbers that are not in this list, all the numbers in this list up top, the sample space, which are not in A, okay? So as we go along this list, I'm going to check these off. 2 is in A, so I can't use that. 4 is in A, darn, can't use that. 6, hey, that's not in A, I can use that. So that's going to be my first one, 6. 10, that's not in A. 12, hey, that's not in A either. We're on a roll here. So I'm looking for all the numbers that are not in A. And it looks like 17 is not in A either, but 18 is. So we're going to have a list made of all these numbers up top that are not in A. And I think that's it, because 27 and 29 are also both in A. So 6, 12, 7, 6, 10, 12, and 17. Those are all the numbers not in A. And the numbers not in B. Remember, that's the translation of this thing. It says not B. Well, 2, 4. I think 4 is not in B. Let me clear this space up here so you can see what I'm doing again. The number 2 is in B. The number 6 is in B. The number 12 is in B. The number 17 and 29 are in B. So I'm going to grab everything that's left. That's 4, 10, 18, and 27.